the things that we should make clear first when we talk about innovation by design is that as a population, we are not good at predicting the direction of dramatic change. And that's not just true for people generally who maybe aren't experts. That's especially true for experts. When you look at the big changes that have come along in systems of innovation over the years, all over the world, we have done a very bad job of predicting them. So take, for example, the World Wide Web and the Internet. Today, especially if you talk to people who are so young that they've never known the world without the Internet, we can't imagine life without the Internet. I know my kids often, in the middle of a conversation, will fact check on their smartphone in the middle of a conversation. It's taken for granted that we can have access to the world's information. But if you go back to 1992, 1993, the very early days, the Internet existed, the World Wide Web was just being created in terms of a massive system where lots of different computers could go in and then take content the way that we now take for granted. We had no understanding of where that was going. It's actually very interesting that at the time, our experts said there was no need for the World Wide Web, including those who had invented the technologies for the World Wide Web. I remember Bruno de Leon, who was a French software developer and entrepreneur, had created a company that based on a software that did manipulation of photographs. And back in 1992, 1993, Bruno was a visitor in my class on organizational growth. And Bruno took the stage after we talked about their technology, and he talked about the future. And he said he envisioned a future where lots of people would go onto computers, not to use the computer, but to access photographs from other people's computers. Now you hear that today and you say, but of course. Well, I can tell you at the end of that class, when I looked at my class ratings, they were fine, except for the Bruno de Leon session. And the students were convinced that this guy was out of his mind and that we shouldn't be having him back in again. And yet he was the one person I remember from that era who was actually talking about the way we use computers today. And when you go through the archives, as I have done, you find there's very little understanding of where technologies are going. So that's the first thing I think we have to get clear. We aren't good at predicting innovation, and our experts are particularly not good at predicting innovation. But a second point to make when it comes to understanding innovation is that we're really good at retrospectively rationalizing once an innovation comes about. We quickly realize collectively what the meaning of an innovation is and come to assume it. And obviously the web is an example of that. We now take for granted that it exists. But another great example are these business school case studies that you often read about successful companies. They're often written up in a way that seems so compelling, that the opportunity was so clear. Often, the innovations are talked about as if they were planned. I was sitting on University Avenue in Palo Alto, enjoying the sunshine a couple of weeks ago, and I overheard a couple of people probably in their 20s talking about Facebook. Now, I've followed Facebook since its beginning with case studies, and most people know about the road that Facebook has followed to success as being one that really emerged through lots of different unexpected developments. And yet to hear them talk about Facebook, the platform strategy, the monetization model, you would think that it had been planned by a master chess player. And it's that kind of retrospective rationalization that we're so good at. In a way, we look at companies often the way we look at a person's career. You know, a company's strategy is a lot like a person's resume. It is a retrospective rationalization of that company's life, just like a resume is a retrospective rationalization of your career. It's accurate, factually. Your resume is accurate. But there's nobody's life that really reads like a resume. Now, I raise this topic of the resume and rationalization and retrospective rationalization of businesses not to be cynical, but to be honest about the fact that what unfolds makes sense to us only in retrospect. And as humans, we are really good at retrospectively rationalizing. Not only that, it is our job as a leader to retrospectively rationalize why our firm wins or why our firm loses. So I'm not cynical at all about retrospective rationalization. I just want to point out that that's what goes on in organizational life. Now, when you put these two facts together, number one, that we are not good at predicting innovation, and number two, that we are really good at retrospectively rationalizing, it creates a problem. We tend to be very bad at organizing for innovation. And to explain my point here, let me tell a story. I remember going to Singapore in the late 90s to lecture on this same topic, on organizing for innovation. And as many of you may know, Singapore as a system, as a city-state, as a society, is extremely good at planning. And you only have to go through their airport to enjoy the fruits of that. I often wish that many of the other airports of the world would outsource their operations to Singapore, because Singapore is so good at planning. Now, as I'm there in Singapore, I noticed in the mall that was by the Westin Hotel, there was a street musician playing a guitar. And he was very clean, had a poncho on. It was air-conditioned, of course, being Singapore. He was singing Peter, Paul, and Mary songs, Puff the Magic Dragon or something like that. Now, all my education took place in Berkeley, so I know about street musicians. On average, they don't sound that good. They're not very pleasant. They often are not someone you'd want to hang out with. These Singapore street musicians were actually very nice people. They looked approachable. And in fact, there was a second one that I saw that night in the lobby of the Shangri-La. Now, at that point, I knew that there was a pattern. Nothing happens in Singapore by accident anyway, never mind twice. Well, come to find out that the campaign that was going on in Singapore that year was to increase creativity and spontaneity. And these street musicians were part of that campaign. Now think about this. Let's think about the innovation process. What's going on in the case of the Singapore story? Here's a distribution of possible outcomes. And you don't know what you're going to get in the innovation process. Some of your outcomes, in fact, are very unpleasant. So here's my technical symbol for that. Some of them are going to look like genius later. And who knows what the real distribution looks like. Here I have most of our innovations being sort of in between. And think of musicians, for example. We want to have a musical genius come out of a system. We want to come up with the next Neil Young or Bob Dylan or whoever you see as a musical genius. But the system's going to give us lots of riffraff along the way down here. Well, Singapore looked at this problem. They said, we would like to have creativity. So they managed it. They know how to plan. But in that planning, what do? Here's the distribution of outcomes they produce. We're not going to have any of that foolishness, first of all. None of those avoidable street musicians I used to see in Berkeley. The implications of that planning is that neither will we have genius over here. In a sense, the price of genius is foolishness. When we manage the innovation process, look what we do. We manage away variance. The key to innovation is variance. Yet most of our managerial systems, right, there's our variance. Most of our managerial systems manage for the mean in here. And this is the problem with managing innovation, especially given the way that we retrospectively rationalize. We think, of course, we can identify innovation. But no, we only identify innovation after we know the difference between the fools and the geniuses. And that only happens once we allow variance to take place. So one of the biggest problems we face in the management of innovation is the fact that we tend to manage away the variance of the system. Therefore, while we get no foolishness, neither do we get genius. So what do we do? What are the implications of this? Well, it turns out we can manage to increase variance. We can think about increasing the variability of what is produced by a system, but it requires a very different philosophical approach to how we lead organizations. And if I had to boil it down, Dina, I would boil it down to this following statement. Our job in leading innovation is not to know the future. Our job is to create the system that discovers that future. And that means creating organizations and larger ecosystems of organizations that have high variance as one of their characteristics, that produce lots of foolishness and failure as the price we pay to get those moments of genius.
Bill, we've had a bunch of questions already about what you've been saying, some about using models to look at what's happened in the past and try and predict what might happen in the future. But then you just mentioned having all these different ways of innovating, I guess, doing different work. So how do you do that? How do you take an organization that typically develops one or two products and allow for that type of innovation or innovative work?
Yes. Now, of course, there's a tremendous amount of work on this, Dina, with respect to managing the innovation process. And I think if I had to boil it down, especially when we're talking about predictive models, remember, every model predicts a distribution of outcomes. It has an on-average prediction, but it also has, if you will, a variance. And so, in a way, our best models, the ones that are most accurate, are the ones that are, in many ways, minimizing variance. So ironically, while they'll do a very good job of predicting those things in the future that should follow from what we've already experienced in the past, precisely for that reason, they'll do a very bad job of predicting completely new realities. And let me give you an example. I studied the evolution of the computer industry in a book that I published a few years ago. I'm not plugging the book. In fact, my wife describes it as a book that was written not to be read. So I'll sum up everything you would ever want to know out of that book in the next minute. And so don't bother with reading it. But in looking at the history of the computer industry, the early firms, those in the mainframe era, were tremendous at modeling changes as they were taking place in terms of the mainframe computer. It wasn't just IBM. There were a number of firms involved. A tremendous amount of technological expertise took us from the very early computers through to computers that were used in large-scale industry and government and military and so forth. Now, famously, and probably most of you know this story, computing changed coming into the 1960s, moving into the 1970s and into the 1980s. During that period, there was a shift towards what we now talk about as distributed computing. This is prior to the personal computer, prior to the microcomputer, a shift in the logic of computing. If you do want to read about it, actually, the novel Soul of a New Machine is a great reference for that. Many of the companies that were starting up then began to use a new term. The term was hacking and hacker. There was a hacker code of ethics that said computing should be accessible to all, that there should be a much more distributed bottom-up approach. Now, albeit the fact that most of the people involved in that movement had the largesse of Stanford and MIT at their disposal, so it wasn't quite a populist movement. But nonetheless, the idea was that you could access computers from a distributed system rather than through a centralized mainframe system. Well, it turns out that that logic, everything about that logic of organizing, competing, designing computers was so different than anything that you could imagine in the mainframe era, that all those models of the development of the mainframe computer that emphasize scale, and economies of scale were, in a sense, disrupted by this movement to distributed computing. The better you did at developing the mainframe, the more inappropriate was everything about what you did for distributed computing. And therefore, the mainframe firms that tried to move into distributed computing failed. Now, here's what's really ironic about this. Once the distributed computing firms came to blossom, the digital equipment corporations, Data General, many of these much storied, innovative firms, they were talked about then as the obviously novel, disruptive organizations. Well, then along comes the microcomputer. With the microprocessor, the microcomputer is yet again another logic of computing that was completely different from the design characteristics of distributed computing systems, required a different kind of organization, much more focus on distribution, much more of an inclusion of the general public and retail markets and so forth. Completely different approach to software design. As late as the early 1980s, in the Stanford Library, there still are books on the computer industry that dismissed the microcomputer as a toy used for trivial computing purposes. Once again, a disruption had come along where our old logic didn't apply to the new logic. The old models weren't good at predicting the new development. And the new developments were taking the world in a completely different direction. Now look, I bring up this example not because it's exceptional. These kinds of changes, these completely unexpected transformations of industry through innovation happen across all industries and are happening at an increasing rate. My point is that the models that predict, because they're based on history, are particularly bad at predicting how these innovations will take place. The economy, in different economies, are better or worse at this, but the economy allows for lots of variance. And so the high variance parts of the economy are the parts of the economy that come up with these innovations. You know, many people come to Silicon Valley in order to understand innovation. And they will come from other countries. They'll say, we'd love to have a Silicon Valley. And the very first thing I say is, well, let's look at your failure rate. And you often get surprised. They say, no, we'd prefer not to have failure. We want to have innovation. I say, but of course. But the best predictor of innovation that is genius is whether or not this system is allowing for failure. Because that tells me it's a high variance system. And it's a high variance system that produces both genius and folly, and typically upends the models that were predictive in the past.
So this is amazing. We've had a lot of questions about that. And first, someone was asking about, can't you just respond quickly to other changes that are going on? But then when you look at the technologies, it doesn't seem like you could really keep up. So it seems like you need to have a large group of people working on lots of different projects. And so can you talk a little bit about how do you do that? How do you make it safe for people to fail in a company, knowing that you have no idea what's going to happen in the future and that one of those things might be the new direction of your company?
That's a good question, Dina, and it's typically the one that comes up at this point. Once again, there is a lot of work on this. I guess to sum it up, I would say that what matters most is knowing whether or not you're trying to capitalize on existing technologies or whether or not you're trying to move in directions that are likely to be disruptive. Because look, when we're trying to capitalize on existing technologies, we need to focus on what is already known and plan for time to market given those technologies. Let's talk about Seagate as a great example of this. When Steve Lusso initially took over as CEO of Seagate, and now I'm going way back to the late 90s, right around the turn of the century, that company was a technological leader that had been perennially unprofitable. And when you look at why, it had to do with the fact that it was constantly lagging in time to market. Well, Steve shifted Seagate at that time to a time-to-market strategy. And the way he did that was to remind the organization and really move the culture and structure and routines of the organization to emphasize using only existing technologies so that they could make customer-defined time milestones. Right? So if you're going to come out, of course we're going back in time now, but you're coming out with, say, a 20 megabyte disk drive that, say, a consumer products company like a Dell, or maybe a disk array firm like an EMC needs by a certain date, then you got to make that date. And if you're going to miss that date and not have those technological specifications because you were trying to push the edge of technology, that's unacceptable. So interestingly, Seagate became much more responsive on time to market, but it did so by focusing on existing technologies. Meanwhile, simultaneously, in a separate part of the organization, Steve Lusso and his team put together Seagate Research, which was based back, it's a long story, I won't tell you all the details, and I write about it in my teaching notes on my blog, but it was based elsewhere. It was separate from much of the organization's production processes. And that part of the organization did a lot more blue sky research in the fundamentals of material science so that they were ready to begin to incorporate solid state memory and other kinds of memory, which we now see combined with what you'd think of as traditional disk drives in the much more hybrid products that you see today. So there were both of these efforts going on. Here at Stanford, our professor Charles O'Reilly has done a great deal of research on this mixing of the focus on exploiting what we know and the organizing to explore what we don't know. But I have to say that even though there has been a great deal of work, especially by Professor O'Reilly and his colleagues on this difficult problem, it is a problem. Because after all, let's go back to that distribution. Okay, so if this is this distribution, who knows what it's actually shaped like? Perhaps it's skewed differently. And down here we have these ideas that aren't going to work out. And up here we have these ideas that are going to work out. In the economy, when these innovations come along, the economy draws a selection threshold. Okay, and these firms, these efforts, these innovations are going to be deselected. And the evolutionary process of the economy leaves us with these successful firms. You have to ask yourself, where do the costs of failure go in the economy? And the answer in capitalism is that those costs are what the finance markets, in a sense, distribute across risk takers according to the level of risk that is seen in these projects. So capitalism is actually reasonably good at allowing for this kind of an experimentation process. When you try to explore for new possibilities inside companies, in a sense, you bring inside the company these costs, which means wide open blue sky innovation could be cost prohibitive. I mean, to put it another way, if you really want to win the lottery, you'll buy all the lottery tickets, but that's not a, as business school professors would put it, positive net present value proposition.
Bill, we have a bunch of questions on that as well. And so even if you have your research area or even a group of people who can fail trying to create that sense that you can fail, how do you reward the failure?
Yeah. Well, it's a tough thing. And I think one of the ways to look at the problem is to break the different techniques of organizing and leadership into the different parts. Some are easier to deal with than others. So let's look at the easiest to deal with, and that would be the sort of architecture and routines of your organization. Reporting relationships, structures, incentives. Those you can typically manipulate reasonably easily compared to, say, changing the kind of people that work in an organization or changing the culture of an organization. Those are harder to deal with. So if we look at the easier to deal with techniques, the organization's structure, its routines, there what we see is that the most innovative organizations are, on the one hand, structured in a way that they separate out those who must make the numbers on a quarter-to-quarter basis from those who are exploring for new possibilities. And it's, once again, Professor Charles O'Reilly's work that has looked a lot at this separation of the different parts of what he terms the ambidextrous organization. But also then if you look at the different routines, and so for example incentive systems, which were implied by your question, Dina, the jury's out. Incentive systems can become too complicated. If I had to boil down what I've seen in the research so far, I would say it's not exactly determinant, but there is some evidence that incentive systems that work on behavior rather than outcome are more forgiving with respect to failure. All right, so think this through. If someone is your direct report and they've done what in your book are the right things with respect to a process of innovation, but it hasn't worked out, you can reward them for having gone through the process of innovating, even though in that particular trial it hasn't worked out. We can take a great lesson here from the world of entrepreneurs. The big movement now in entrepreneurship, following the work of Eric Ries and Steve Blank, really takes us back to the old theories of the great Professor James March. Many of the ideas that I'm talking about on innovation came out of James March's work. And if you had to boil it down, this approach says as follows. It's written at length by Ries and Blank, as well as James March and his students. But if you had to boil it down, the innovation process comes down to this. We try something, we find out why it doesn't work, and then we update. And, for those of you who studied the scientific method in school, you have your theory, which we're going to call a strategy. And then you take that and you test it empirically, as a scientist would in the sciences. We're going to call that the market or the customer. And then based on what goes wrong here with the customer, we update the strategy. Now, if we spend a lot of time up here in a planning process, planning the strategy, we better hope to be right, because we put a lot of money into it and sunk a lot of time. If instead we minimize how much time we spend planning and as quickly as possible go to the customer, we learn why we're wrong more quickly and go through this iterative process of learning, which, as many of our viewers know, has become very popular in Silicon Valley, in the lean startup movement. And in fact, many large organizations are using when they engage in agile development processes and other such processes that rely on iterative improvement. Now remember, the secret to iterative improvement is not getting it right initially. It's getting a process of learning in place so that we converge over time on a better solution through trial and error. Now, there are a lot of problems with this. And so I'm not saying this is a panacea. I remember being asked to speak on this topic to a group of airline executives in a restaurant that was overlooking San Francisco Airport, which would have been fine, except that down on the runway was the burned out hull of the airliner that tragically had crash landing at San Francisco Airport here about a year ago. And it was very difficult for me with a straight face to talk about the importance of failure and the need to fail to a bunch of people in the aeronautics industry overlooking the burned out hull of an aircraft. I don't want a lot of foolishness if someone is running a nuclear power plant. There are lots of times we don't want to see failure. In fact, if I want a nuclear power plant run, I probably want to put Singapore on the job, because we're not going to see any foolishness. So you have to do this kind of approach to innovation in an appropriate way. And it may be that a lot of prototyping and developing goes on behind the scenes before a product is declared ready for launching as a final product. If you look at the American changes in the American healthcare system, it wasn't surprising to a lot of us here in the Silicon Valley that the initial rollout of the software to sign up people for healthcare had a lot of problems. That's often how software is developed. It was clearly inappropriate to run the experiment in real time on the American people while they were supposed to be signing up for healthcare. You really should have gone through that iterative process of development in prototypes on test markets in advance so that the rollout ends up being a much better product. And yet when you look at those who are now retrospectively rationalizing the flawed rollout of the healthcare software, there's a lot of talk about, couldn't it have been planned better? No, this wasn't an issue of planning. It's that the development process for something really different requires lots of iterative learning, and that wasn't built into that development process in advance.
So we've had a few questions on how to finance innovation. So how much money, is there any research that tells a company how much they should be spending on people who aren't really creating anything that's going to come to market quickly?
Yeah. Well, it turns out that it is very difficult for firms to imitate venture capitalists. And so I don't know if the question really wanted to go at that. Let me go at that issue, though. So the venture capital community is a very different approach to finance than what we see in many other communities. One of the prominent venture capital firms here in Silicon Valley, for example, had a bit of a crisis a couple of years ago. Some of my colleagues were among their leadership, and I was very interested to hear how they dealt with the crisis. They had found they had a real problem with the failure rate of their portfolio companies. The problem was that their failure rate was going down. They were becoming concerned that their access to deal flow, their view of what was going on in terms of new venture creation was perhaps becoming too conservative. They were getting not enough foolishness. Now, that in itself wouldn't be a problem, except that it might imply they're not getting enough genius. And so once again, going back to that model where you want to increase variance, the perspective of the venture community is, of the most successful firms, is to magnify that variance. And not because you're trying to make money out of 90% of your ventures. No, you're only going to be making money out of a very small proportion of your ventures. Now that model works well for firms that specialize in it and come to understand the logic of investing for variance sake. It does not work so well, the empirical record shows, for corporations. For businesses, it's often very difficult for the internal corporate venturing arm of business to, in a sense, imitate what goes on in the venture capital community. That empirical fact itself should cause people inside large corporations to think twice before they try to play the game of the venture capitalist. I think it's much more important for businesses to have strategic direction, to understand why they go to work every day, and to try to make good on the investments that are already in place. And let me return again to the example I gave you earlier of Steve Lusso at Seagate. For years, ever since solid-state flash memory came along, people have been worrying about what would go on with the Winchester and the disk drive and so forth. And yet during that period of great concern, Steve and his team managed to continue to make money, and there have been ups and downs in that business, as there are in any business, but they could not take their eye off the ball that they were supplying large numbers of storage devices to companies all over the world. And that is a very different strategic task than experimenting and going in new directions. Do they need to have that kind of experimentation? Absolutely. But that doesn't make them venture capitalists. The venture capital business is a very different business, and I would caution firms that try to simply imitate the venture capital model.
So going back to the rewarding failure, how long do you let someone go on a path of something, and I'll just stop with that. How long do you let it go? And then how do you communicate that to the rest of the company so that the people in the company who are working on something that's failing all the time aren't seen as lesser? than the people who are creating the products.
Yeah. You know, Dina, this is the big question. This is the million-dollar question, right? So let's take a look at the way that great change comes about. If this is the performance of an organization, and we know these performance changes over time, right? So we're going to have performance changing over time. When we're here, in terms of our performance, let's say if we stay the course, we would just keep performance as is, just hypothetically. But if we move in a new strategic direction, there's going to be risk, of course. But we have a vision of getting to a much higher level of performance by making a strategic change. The trouble is, we have to get from here to here, right? We have to somehow get up there, and the execution of this is not immediate, which, Dina, in your question, is the underlying issue. Here's what actually happens when an innovation is successful. When a big innovation is successful, it actually makes performance worse initially, until at some point, and this varies by context and the nature of the innovation, we end up improving performance. And of course, the exact shape of this curve can vary. Some people talk about it as the so-called J curve. Now, this is a problem, because if we're down here, and you're working in an organization down there and things have been getting worse, you're looking at leadership saying, I'm not sure what you folks are doing, but things are worse today than they were yesterday. And then if leadership stays the course, they say, yeah, but now look, things are even worse today than they were yesterday. And when we talk about leadership, often leadership in a process of innovation has to make clear the logic of what must be true up here, which helps your people understand why it is that we're having to endure this difficult process of change in order to get there. That's why strategy is important. Getting back to that iterative learning process I was describing earlier, things might not get better as we iterate. We might be learning about changes we have to make that are especially difficult. Lots of end-to-end solutions that require the whole system to shift are very difficult. I remember when years ago, the folks at Qualcomm were talking about a future. Irwin Jacobs, Paul Jacobs, and their team were talking about a future where the wireless system would move large amounts of data. Now today, of course, we take that for granted in the retrospective rationalization process that I was talking about earlier. But at the time that Irwin Jacobs and Paul Jacobs and that team at Qualcomm were first talking about that future, there was a tremendous amount of debate about whether that was true. In fact, in testifying before the European regulators on the subject of whether the standard that Qualcomm was developing, so-called cdma technology back then, and of course there's been a lot of technical change since then, but in that debate, which is now a couple of decades ago, the European regulators in fact chose to not allow cdma technology into the European system because they were unconvinced that it was going to be effective. There had been professors here at Stanford who had, engineering professors, who had published that the ideas behind Irwin Jacobs' innovation violated the laws of physics. So a tremendous amount of disagreement. And yet the folks in the Qualcomm team remained convinced that although it was difficult at first, that ultimately if they could get a system in place that allowed for the efficient digitization of data, that we would be able to do a tremendous amount of movement of that data among small handheld devices, which of course turned out to be true. But it was much debated for years when those systems were really, those of you who lived through that as consumers remember, it was hard to get a phone call, never mind pull up a website or make reservations, all the kinds of things we do today. Now we're closer to having fulfilled that vision, but getting from here to there is a very difficult road. It requires a belief by people and organizations in their strategy. It requires leadership that aims at that end state. And what's interesting is it doesn't mean that the leaders know all the details about what will have to unfold to get there, but they know what the end state is, and they help their people understand the logic of that business.
Wow, I'm just thinking about that a little bit, because how to communicate that to everyone and how to be a strong leader sounds very challenging. Can you talk a little bit about how you might help the organization move towards, I guess, having that sort of strategy and having that sort of leadership that can really stay the course?
Yeah, that's a good question. I mean, we've seen it happen in the form of strong leaders, as you say, Dina, and obviously Steve Jobs comes to mind. When I give leadership lectures around the world, I often ask the audiences that I face the question, what is an example of a great leader? And one of the things I find so amusing is that I'll often have military leaders, religious leaders brought up, depending on context. I've had audiences name as examples of great leaders Genghis Khan, Jesus Christ, the Prophet Muhammad, Mahatma Gandhi, Napoleon, Vladimir Putin was brought up recently. You can guess where I was. But in almost every situation, people name Steve Jobs. And clearly he's seen as the icon for this kind of visionary leadership. People used to say that Steve was surrounded by a so-called reality distortion field. Now the point there is, if Steve believed something was possible, it often helped others to come to believe that that was possible. But here's the problem. Prior to Steve's fantastic successes in recent years, before his tragic and early death, prior to that, if you go back into the 1990s, Steve Jobs was often looked at as an example of bad leadership style, and it's hard for us to even imagine that now. But there were case studies about Steve using a very dogmatic approach to leadership and firing people when maybe that wasn't appropriate. Steve's own board unseated him, as people may know if they've read about the Steve Jobs story. The jury was out. So if we go back to our J-curve, there were times for Steve when he was down here. And at that point, a lot of people had doubts about him. It's also true that it wasn't clear that Steve knew what Apple was going to look like once it came up here. What he did do is he put in place a system that could discover it. And so, I think you want to think about that in terms of what we do as leaders. As leaders, it may be that we don't actually know the direction the organization needs to go in, but instead we want to create a system that can discover it. One of the ways I like to help people think about this is to run through the following thought experiment. Ask yourself this question. When you have a good idea, does everybody have to agree with that idea for it to be correct? And most people, if I ask them that question, will say, well, no. I'm my own person. I could come up with an idea, and even if people don't agree with it, it might be correct. And yet, when we have an idea, ask yourself, what's the first thing we do? We ask people. We turn to other people. We say, what do you think of this? And if the people we ask don't like the idea, what do we do then? We often ask someone else. So what is it we're doing? On the one hand, we say we don't need to have everybody agree with us in order for an idea to be good. On the other hand, we tend to really care about what other people think. Well, here's what I think's going on there. So just bear with me as I run through this. Okay, look. When we have an idea that's innovative, we might be right. But, of course, we might be wrong. And the more interesting the idea, the less we can know in advance which is which. Or to put it another way, if we know in advance, we have enough information to know the difference between genius and foolishness, the idea isn't that innovative. But what we can detect right away is whether or not people agree with us. If we ask other people and they're all agreeing with us, we've got ourselves a consensus idea. If we ask other people and there's a lot of debate and a lot of the people that we ask do not agree, let's call that a non-consensus idea. Okay, so look at the situation we're in. What can we observe? We can observe whether people agree or whether they don't agree. What do we wish we could observe? We wish we could observe whether we're right or whether we're wrong, and we can't tell. Now, for sake of discussion, let's imagine we're right. Where would you rather be if you knew you were right? Well, if you think that through, look back at that Irwin Jacobs story. You want to be non-consensus. Because if you're right, and people are saying you're violating the laws of physics, in the end, you're going to own all the intellectual property. You're going to have a tremendous advantage. And in fact, when you hear of the tremendous amount of intellectual property payments that go to Qualcomm, those were earned by that firm being in the right non-consensus box early on. If everyone already agreed with us, we'd all be right. That's fine. It's just not as profitable as being right in a non-consensus sense. But Dina, now look at this. What if we're wrong? If we're wrong, where do you want to be then? And there is no doubt. If you're wrong, you just don't want to be alone. Because nobody wants to be here. This is the fool. And the big problem we face in trying to manage innovation is that the fear of being a fool is often much stronger than the hope of being a genius. Because of that, odds are people in your organization have ideas that they are afraid to come forward with. People will side to consensus thinking even though they might have brilliant ideas. And the question you have to ask yourself as a leader is that have you created an environment in your organization where it's safe for people to risk being a fool? And if the answer to that is no, you are not going to hear the ideas that potentially are genius.
Wow. Again, can't help thinking about how you know on the J curve, how you know if you are actually on the J curve versus just heading towards a failure, and how you help people who don't like change.
Yeah.
So again, you're heading in this path. You're trying to help people fail, and you're trying to find the genius, and you're surrounded by people who want results and who don't sort of, I guess, honor or respect the failure. So how do you help the fool?
Yeah. You know, it's constantly around the business school, Dina, we hear people saying, you know, I've come here to learn about best business practice, or we've come here to understand how to interpret the evidence we're getting in our quarterly results. We're very inductive from data that way. We want to see the results. How can I tell? How can I model this? How can I know? If the idea is really innovative, you can't know with respect to the experience of the firm. There is risk. That's unavoidable. What we can do in advance is elaborate on our logic. The Stanford Business School in our new curriculum has focused greatly on helping our students think logically about strategy. And the reason we do this is that what leadership can do is offer a logic for where it is the firm wants to go. Now, that logic can have flaws and will need to be updated in an iterative way as evidence comes in. But the nature of innovation is that if the innovation is big enough, we don't have the data now to know. We didn't have the data in 1990 to know how we would look at the World Wide Web by 2000. We didn't have the data when they were first making social network sites to realize that they would be platforms for sharing pictures within 10 years of their founding. And we can go through example after example, such as we've done over the course of this webinar. But what we did have was the capacity to engage in logic. And it is a primary job for leadership to help their people understand the logic of the business. The strategy is a retrospective rationalization of what we've done as a firm, but it is also a roadmap for the logic that should get us through the J curve. Are we going to be right? Of course not. In fact, we need to build failure into the system as we discover our way through the J curve. But without leadership and logic, if all we're relying on are short-term results, we are never going to take the kind of risk that gets us to that much higher level of innovation.
That's great. You know, I want to just mention that if we were in one of your programs, which I highly recommend, people would have time to ask you questions throughout the presentation, but also to talk with you on breaks and at meal times. And so we have a lot of questions that we're not going to be able to get to, but I just want to make sure that everybody's aware that in our programs, you get to continue the conversation, both with the faculty member and with the cohort. And so we don't have a huge amount of time left, and there are a lot of things that you've said that I want to make sure that we repeat and get out. And so if you could just come back to sort of the communicating failures. I mean, I think you've touched on the strategy, which is really wonderful, but maybe we could just end with how you communicate the failures so that everybody doesn't make the same mistake again, or that maybe someone else can find that path and move on.
Yeah, you know, it's a difficult thing. And I brought up the example of Qualcomm before, and I'd like to raise it again as an example. The chief learning officer at Qualcomm is a woman named Tamara Elkelis, and has provided, I think, a lot of us with a tremendous example of how to deal with the question that you asked, Dina. It's been a very successful company. She's been their chief learning officer for years. What's interesting is, as a C-level officer right there with top management, she's been really pushing on the innovation process. And in particular, when you come to be a Qualcomm employee, like every firm, you go through an initial process of orientation. What's interesting at Qualcomm is you will hear films, and many of those films are top-level Qualcomm leaders talking about their greatest failures. And you know, from the beginning, they focus on the fact that well-intended behavior that leads to failing outcomes have very good implications. Obviously, you don't want behaviors that are against policy or in some way nefarious. That's not what we're getting at. But we're talking about people trying to do their job where there's an inherent element of risk and things don't go well. If that's a career-ending event, people throughout an organization know that, and then they get very conservative. And the great innovative organizations of the world try to create a culture where in some contexts it's safe to be innovative.